So far what we've learned is that for every project, we try to make an activity diagram, right? So that activity diagram could be anything. I mean, let's say A is a start, start, A, B, and C. Let's say A is 2, B is 3, C is 10, and this is, let's say, finish. Now, if I ask you what is the critical path, so the easiest way is find all the paths. So there's two ways. One is a longer way is you find the EST, you find the LST, find the float on every activity, and pick up those activities that have float equals to 0 as your critical path. Right? That's one way of doing it. That's a longer way of doing it. The other way of doing finding the critical path is, and again, if you don't remember what is a critical path is the minimum time that is required to finish your project. Right? The minimum time. You remember we took the example of eating the breakfast, downloading an email, reading the email last week, right? So if it takes 2 minutes to download an email, 3 minutes to read an email, and 10 minutes to eat the breakfast, then how much, by what time, and if this guy is starting at 8 a.m., what is the minimum time this guy will be out of his house to catch a bus? Is 8:10 a.m. Why? Because in the first, he can simultaneously start eating the breakfast and reading the email, downloading the email, and then the first 2 minutes, downloading finishes. The next 3 minutes, reading finishes, but he continues to eat his breakfast till the end, 10th minute. And he's out of the home at 8:10. Now, if I ask you what is the critical path? Critical path is C. That means you cannot delay C. If I say delay C, that means let's say at 8:10, if he doesn't go out of his home, he misses his bus. So if he delays eating his breakfast by a minute more, he misses the bus, correct? So that is the critical path, where you cannot delay even a single second. The moment you delay, the project is gone for a toss, right? So C is the critical path. And I said, what is float? Float is how much can you delay an activity? Can you delay C, eating the breakfast, even by a minute? No, right? Or you miss, if you have to finish by 8:10, can you manage to delay this? No, right? So the float here is 0. That means, sorry, I can't delay this. Float means the slack, the elasticity, the leeway that I have. What about this one? Yes, I can delay this until what? Maybe until, let's say this is total, it's taking 5 minutes, downloading and reading. So that means I can delay A to 6th minute, first 6 minutes, right? So 6 and 7, this guy downloads the email. So what I'm doing is A, B, C. A takes 10 minutes. You can delay 6A by 5 minutes. And on 6th minute, you start A until the 8th minute. And then 8, 9, 10, you start B, and you're still out by 8:10. Right? So you can delay A by 5 minutes. And you can delay B by 6 minutes. After that, you cannot delay them. So the float on A is 5. And float on B is 6 from the beginning, right? Make sense? But then there's no float here. The moment I delay this, I'm gone. Right? That's the basics from the last week. Now, crashing tells me that, let's say this guy has to leave by 8:09. rather than 8 or 10. Then he has to do something quickly to finish this up, at least a minute. So what he can do is he has to eat his breakfast a minute early. That's the only way to go, right? Now, forget about eating breakfast, right? But then let's say if you are digging a hole in the ground, and let's say one person take 10 days to dig a hole on the ground. So that's the critical path. That means you cannot prepone it. That's the maximum you can take out of one person. But then if you tell that person, no, I need to do it in 5 days. So what exactly do you need to do? You need to employ one more person, right? You need 2 people now, so that they come in together and do the work in half of the time that you are after, that you were spending earlier. So when you add people here, what are you spending? People don't come for free, right? You're spending cost. So if whenever you are planning to finish your project earlier, you have to spend some cost. Initially, when the critical path to dig a hole was 10 days, you reduced it to 5 days. So you reduced the critical path by spending some money. And that is what is called crashing. So you crashed the schedule from 10 days to 5 days by spending some cost. So that is called crashing. Crashing is, by definition, reducing your critical time by spending cost. Let's see how. Alright, make sense? Any dramas here? Cool. Let's now quickly see a question, and that'll make more sense. So that's the example. Let's try to crash it, right? So it says, let's find the paths. A, C, E. Time is 5 plus 4, 9, and E is how much? E is 14. 14 plus 10 is 25, 24, right? B, D, E. B, D, E. 7 plus 3, 10. 10 plus 14 is 24? Sorry, did I? Which one? AC. AC is 20. Yep, 23. Thanks for being attentive. Alright. Now, critical path 24. Let's do the maximum reductions. So it says each of the 5 activities have a completion time reduced by 1 hour maximum. 1, 1, 1. That means 3 reductions. 20. 1, 1, 1. You got 20. 1. What's your critical path now? 21. That means there's no point reducing this any further down 21, because at 20, critical path remains at 21. Let's reduce 23 to 21, basically. That's the goal eventually, right? So I need, is there any cost matrix involved? No. So that means and it's $100 per hour. So I just need a 2-hour reduction here. No. So that means $200. That should be my answer. Yep, makes sense?